Okay, this is Chapter 4, which is about chemical reactions and also a little bit more complex stoichiometry. We'll start with section 4.3, which is sort of general solutions. Starting off the composition of solutions, an important equation when it comes to composition of solutions is molarity, which refers to the moles of solute per volume of solution, and it's always given in liters. So capital M is molarities, and that's moles per liter. For example, if you had a 3 molar solution of hydrochloric acid, or HCl, that could be made by having 6 moles of HCl in 2 liters of solution. So let's look at a practice problem. Here's how I would suggest you work these. Once I've read the problem and explained, I would pause the video and try to work the problem, and then I will put the answer up. In class, we will go over how to solve the problem if you were unable to get the correct answer. So, the question is, a 500-gram sample of potassium phosphate is dissolved in enough water to make 1.5 liters of solution. What is the molarity of this solution? So pause the video here to try and solve the problem. Okay, so some hints on how to solve the problem. First, you would convert grams to moles. 500 grams of potassium phosphate, which is K3PO4, is equivalent to 2.355 moles. Once you know the number of moles, you would divide it by the liters of solution, which is 1.5, and that should give you 1.57 molar. The other thing covered in section 4.3 is looking at more specifically the concentration of ions. So an example is if you had a 0.25 molar solution of calcium chloride, in water it would ionize and break down to calcium ions and chloride ions. In order to determine the concentration of the ions, you have to take into account how many molecules are present. So you have 1 calcium, so that means the concentration of the calcium ions is 0.25 molar, but because you have 2 chlorines, you have to multiply the concentration by 2 to get the concentration of chlorine ions. So let's look at another example. If you were given the following problem, and it asked you, which of the following solution contains the greatest number of ions, what would you say? So think about it, pause the video here. All right, if you said that solution B had the greatest number of ions, you would be correct. So if we look at A has 0.08 moles of ions, right? You have 0.4 liters, and each of the ions, sodium chloride, is going to break off into 1. So you have 0.1 molar of sodium ions, 0.1 molar of chloride ions. For B, it contains 0.09 moles of ions. You have 0.3 liters and 3 different ions at that concentration. 1 calcium, 2 chloride, so it would be 0.1 times 3. C contains 0.08 moles of ions. And D does not contain any ions because sucrose does not break into ions at all. Some important things when it comes to concentration of ions is that the solution with the greatest number of ions is not always the one that has the most volume or the highest formula unit. Next up in section 4.3 is dilution. So dilution is when you add water to a concentrated stock in order to achieve a desired concentration that would be less than what you started with. It is very important that you guys understand when you dilute with water It's not changing the number of moles of solute present. It's just changing the concentration. The moles of solute before dilution will always equal the moles of solute after dilution. An important equation when it comes to dilution is M1V1 equals M2V2. So that's concentration times volume of one solution is going to be equal to the concentration and volume if you were to change one of those. We'll do an example. If you had a 0.5 molar solution of sodium chloride in an open beaker and you allowed it to sit on a lab bench, which of the following situations would decrease the concentration of the salt solution? So pause the video here and think about that. Which will decrease the concentration? If you said A, you would be correct. For letter A, adding water to the solution will increase the total volume and therefore decrease the concentration. For letter B, if you pour some of it down the sink, it's not going to change the concentration, you're just going to have less of it. For C, adding more sodium chloride to the solution, it'll actually increase the concentration. D, if you allow water to evaporate, it will also increase the concentration. And since B, C, and D are not correct, E cannot be correct, so the only answer is A. Let's look at another problem. What is the minimum volume of a 2 molar sodium hydroxide solution needed to make 150 milliliters of a 0.8 molar sodium hydroxide solution? This is an M1V1 equals M2V2 problem. Go ahead and pause it here. Okay, if you got 60, you would be correct. The way that you would solve that, for M1V1, you would take 2 molar, multiply that by X, because that's what you're looking for. How much of your original stock do you need? You would have that equal to 0.8 molar times 150 milliliters. When you're solving these problems, as long as both sides are using milliliters, you're okay. Solve for X, and that will give you 60 milliliters. And this slide is the last slide for section 4.3.